All right. Well, welcome everyone to the Q&A session following Ines's talk. Thank you for joining us if you arrived here from Draw Curiosity. So to give a brief introduction, the EVO seminar series is a class at Binghamton University, and what we're doing is we're trying to sort of merge live scientific talks with a science communication angle. So you can see my lovely students in the bar below me. So they are watching a series of 10 lectures and are going to be making educational videos about them. So I'm pleased to welcome Ines Dawson, who just gave a lovely lecture on the evolution of cooperation, and we're gonna have a chat about it.
Cool. Hi, everyone.
Thank you.
Welcome.
Yeah, so I suppose I can start things off. I'm curious, I sent you an email about this, but I'm curious what you think about the concept of selfishness more abstractly, because it would seem that what these various theories of cooperation are doing is that they want to make the claim that all actions at some point need to benefit the actor. Right, and it might benefit the actor down the line because it's, you know, their nieces and nephews are getting to reproduce or something like that. But it would seem that there's this kind of cynical claim that the evolutionists want to make, that like there is no such thing as like genuine altruism of like just giving for the sake of giving or any of these like lofty Christian values. So I'm wondering what you think about that.
So I guess what I like about the biological definition is that it is very specific, which means that you can easily delineate what it is that you're describing it. So as soon as you say it's more abstract, I still feel you need a definition. I'm going to take these off and I'll put them back on when I get questions, because I get weird feedback with them. So I guess it really depends on whether you're saying it's black and white, you know, is something beneficial or bad for you, or would you consider a spectrum along the way? Something is very, very beneficial for you. You know, you might get money or recognition or something that you want from performing an action, or perhaps you're also incurring some losses. I think, again, it's more abstract in that it's more blurred when you consider it from the perspective of pure human behavior. Because when we define it in biology, we're just looking at reproductive output. We've got something that we can, maybe not easily, but something that we can ultimately quantify and put a figure to, and therefore we can say, well, it's positive, so we did obtain a benefit, or it's negative, and if it's something that's mediated by a gene and it's got a negative reproductive output, which is actually bad for your fitness, then you wouldn't expect that gene to spread. So it's not that pure altruistic behavior doesn't happen, but it's just because of the way natural selection works, you would expect that gene to be outcompeted. In a human realm, I think it's a lot more philosophical, and again, you'd want to define what you consider it as such, because even if you like giving for the sake of giving, it is giving you a degree of emotional well-being, which you could consider to be beneficial, but if anything, that would just be a win-win situation. I don't know what you think about that.
I have a quick question. So I'm kind of curious on how like this idea of altruism can kind of create a chain or a chain reaction, and I'm sure there's some great saying that I could drop right now, something like love breeds love, or altruism breeds altruism. But I'm curious if there's any findings in biological research, like something with, like, say, the vampire bats. You know, one of the individuals who receives blood then will later give blood to another individual. We talked about the reciprocity between two. And like something that I thought of in human altruism is something related to a chain of kidney donations. When I don't know if you guys have heard about this, but like when somebody needs a kidney and they might have a donor but they don't have a match, then their donor could then give in to a pool of kidney donors and recipients, and then you have like a large link of donors and recipients that are all connected to each other, and one doesn't work without the other, something like that. So I don't know if there's any findings with that.
So I don't know whether Max sent on this video as well, or just the inclusive fitness one. So there was the video on how obligate eusociality comes about. And there are other good videos made by other people, which I can highly recommend, which talk about transitions in biology, and those generally indicate step changes in cooperation, and that lead to what is considered, on some biological level, a higher degree of complexity. In the case of eusociality, which is my favourite because I love insects, and I love eusocial insects especially, the transition actually it's not an easy one. It has happened at least 4 times, but it's not one that easily happens from one generation to another. In truth, you've got a competition between potentially having more selfish individuals that produce their own offspring versus those who forego having their own offspring to help this queen, and by having that collective pool of help, they're actually able to overall increase their inclusive fitness output. So in those cases where that happen, I would say that overall their fitness could be higher, but you could also see it as 2 separate strategies that maybe on average might work just fine. So as long as the balance tilts the right way for long enough in evolutionary time, you can make that transition to becoming eusocial. And even if later on, after you become eusocial, your relatedness goes down such that actually you're not getting so much of an inclusive fitness benefit as before. Also let me know if this is getting too complex. Yeah, so if that does happen, ultimately you are now sterile and you can't have your own offspring. So it's not necessarily a better situation for you, but it's also the one you're in. I guess you could see some examples of aggregation as perhaps a chain reaction. But the thing is, when it comes to evolution can't really look ahead and try to predict what's going to happen and what would be the best course of action. Whereas really it's more like an algorithm, and whatever works best at that particular moment in time is what wins or is more represented in the next generation, which means that sometimes you can get quite random shifts in genes if none is particularly advantageous over others. But it also means that things such as the tragedy of the commons, where everyone is exploiting this free resource, which is great at this moment in time, but you're not being sensible in the future, then that could also happen. And to a degree, to kind of return to humans, I also feel like climate change, there are lots of people who care about it and who want to protect the environment, but ultimately it's a group effort that everyone needs to do together in order to stop climate change, or at least prevent it from getting any worse. And as long as not everyone cooperates, it could actually look very dire. So off the top of my head, I can't think of any clear-cut example like that, because that would rely on evolution having foresight, which it really doesn't. But it could happen randomly, theoretically.
Well, but I'll jump in there a little bit, and I really appreciated that you immediately went to this major transitions idea, because I think that what we see in humans, where we have these really, really abstract cooperations, where you can drive up to a restaurant and be like, I'll give you these little coins in favor of some French fries, like that. There are all of these intermediary steps, kidney donations or what have you, and you see that in other biological forms of cooperation, like bees or anything else, when a major transition has occurred, because you can afford to have these really, really sophisticated cooperative chains. When it's simpler, it's probably because the organisms involved have kept more of their autonomy. Oh, whoa. Hey, Canis, you are muted. Let me see. Can you unmute yourself? Oh, dear. Audio problems forever.
It wouldn't be a live stream if there isn't a problem at some point.
Yeah. Can you try controlling your mute on your end, because I've unmuted you, but you're still. No.
Do you want to just type it? Do you want to just type it? Someone else. Sorry. Terrible.
All right. She's gonna type it in the chat. Let's see what it says. Yeah, Inés, I really sympathized with all your audio problems in the beginning. It's kind of crazy. We have all this technology and the microphones, they just don't work. Like,
I was just frustrated. I spent a whole hour. It was working fine because I have this other channel. I just practiced the live stream. It was like, good, it worked. Tried it yesterday, also worked. Put it on the official thing, no audio.
Yeah.
Don't really know what I did.
When complexity goes up, you have all these interlocking parts, and the higher the complexity and the more interlocking parts, the more opportunity for the dynamics to fall apart.
Yeah, there are more possible points of failure for things to go wrong. I am seriously impressed by how much literally every single USB port, headphone jack is occupied by something to make this live stream possible.
Kenise, you want to try again? No, it's not going. Just type the question into the box. So it goes. Well, while she's typing, does anyone else wanna chime in?
When I realized I did forget, I think I promised you in the email that I would give some science communication tips or some video tips, and I think that's what I was missing at the end.
Well, maybe we could talk about that. What motivated you to start Draw Curiosity?
What got me started with Draw Curiosity? So I've always wanted to do sort of making science more accessible to people, or basically, I feel there's lots of nice stories in science where you just understand something, you get that very pleasant eureka moment, and I wanted to be able to share some of those moments with other people who might not have encountered those stories. And also, I know it started off being a way of improving my communication skills, and then it just turned out to be a lot of fun to do. I did actually prepare in my head a few tips, but I also thought it might make more sense to ask if there was anything specific that you wanted more guidance with, or creating the videos with. There was a bottleneck in your process.
Well, I'm curious to hear. So this is our second lecture. So some of the videos I've watched have been really fantastic. I haven't seen everybody's yet, but I'm curious. How was the first assignment for you folks? Is there anything you ran into trouble with? Oh, technicals.
One thing I thought I might add is just when we're talking about evolutionary theories, the whole idea of evolutionary theory is that it's very counterintuitive to us in so many different respects. And one of those ways in which it's very counterintuitive to us to think in evolutionary terms is that we're often not thinking of things happening over the course of an individual lifespan. We're thinking of things in terms of these generational frequencies. And so when we talk about cooperativity, it's often not the exchanges that happen over the course of an individual lifetime so much as the exchanges that happen over evolutionary time. And that's that's something to bear in mind is what time scale we're thinking about.
So I guess lots of experimental evolution, so experiments that aim to look and see how evolution proceeds, a lot of them actually use organisms that have very short generation times, because ultimately the pace of evolution, there are various things that dictate that pace. For instance, the mutation rate or your molecular clock in different parts of your DNA, because certain segments of your DNA are actually better at repairing errors than others, meaning they will accumulate mutations faster or slower. But obviously, the faster the turnover of the generations, then the faster you will see that change relatively. So if you take E. coli that reproduces every 20 minutes and you put it under very strong selection, for instance, you could have a heat-sensitive mutant and you could have it at a particular temperature where, say, 99% will die, but 1% are able to cope with that temperature. You would be able to see those individuals that are able to cope in this new environment be selected much more quickly. I realize that for humans, it's a lot harder overall to conceptualize. We also have overlapping generations. But I think to give an example of something that I think people have observed in perhaps the span of their lifetime, has anyone heard of the Flynn effect?
What?
The Flynn effect. I will write it in the private chat, I'm afraid. So basically, Flynn found that when people took the same IQ test, people who took IQ tests in the 1930s, and they set the same IQ test to students every year, overall the IQ of the population has increased. Now, obviously, that depends on what you think is mediating it, because if you think people are simply getting better at answering the type of questions that an IQ test might present you with, you could say it's environmental as opposed to something genetic. But maybe there is some kind of selection towards a greater intelligence in what is known as fluid intelligence, which is generally what IQ attempts to measure. Obviously, IQ has a lot of issues with it and is a bit of a wonky number to work with, but it's something I was reading about recently, and I actually found it quite surprising that the rate at which the average IQ of populations has increased in just 100 years is quite high, and whether that is evolution at a genetic level or perhaps something that is culturally transmitted, I think could be an example of change in real time, or change that we can measure as a process.
Yeah, I'm pretty sure it's got nothing to do with genetics. I've been studying that a lot. I've been writing on intelligence and specifically this measure of G, which is what IQ measures, and how that's just really a failed idea. And it's sad because there are whole swaths of academia that are still looking for like the gene that codes for IQ, and it's like got nothing to do with what's actually going on in the brain, or what's going on genetically.
Yeah, I mean, I guess you're looking at what are likely to. Again, I'm not trying to debate whether it's genetic or not, because in truth, I don't really know. And there is actually quite strong evidence that there is most likely a genetic component, and it's probably polygenic as well. But obviously the environment you're raised in can actually greatly affect development. And I think perhaps some very classic studies ignore the effects of development on the development of any trait. So epigenetics, plasticity, etc. are all very important. I doubt they would find a single gene for it, but when it's an interaction between lots of different genes, or perhaps it's something as simple as how easy is it for neurons to form synapses, or how easy is it for them to form new connections, or to strengthen connections, or to break them, or whether the neuron can communicate with 30 other neurons or 300 other neurons. Probably when you looked at the very tedious additive effects of all of that, you would probably also see changes in behavior, but you would never pinpoint it to a single gene either. So I do agree it's a messy example.
Do we want to go to Kinese's question about eugenics? And back to Nicole and then to Max.
Oh, right, whether eugenics can decrease the fitness of altruism. So you're basically suggesting whether selecting particular individuals would decrease altruistic, the fitness derived from altruistic behavior. Okay, so in a way, if you applied eugenics, that would be a form of artificial selection. You would be favoring individuals with a certain set of characteristics and weeding out others that didn't have it. So that in itself would have an effect because you'd be increasing the representation of certain characteristics in the gene pool. And depending on how many people partook in eugenics, that could be extremely pronounced or actually quite local. Then on the position of altruism, I do think in many aspects, modern medicine, greater acceptance of society in general, and the fact that certain, perhaps, certain diseases, for instance, as a very lame example, I wear glasses. If we didn't have glasses nowadays, I would probably be screwed because I can't see very much without them. Whereas today, to be honest, glasses mean nothing. And perhaps if you are thinking of a very ableist society that wanted to just mate with people that had good vision and therefore have kids that could see well and that would be able to hunt and have more kids than you could expect. In that instance, there's no altruism towards, yeah, I'm mixing up terms here, very muddy from a biologist's perspective. Basically, if you had a strong selection on that trait, then you would expect evolutionary selection against having a trait that doesn't work so well, such as, for instance, me having eyes that are very nearsighted. Now, because we have modern medicine, that can actually improve how much we can see the world around us, and no longer does having bad eyesight affect our fitness directly, because it's got quite an easy fix, perhaps a small economic fix, but not one that's that perceptible. Then the trait of nearsightedness can actually spread to the population, which is something that we have seen. Part of it is also, I will say, some of it is genetic and some of it is actually to do with development. If you stay indoors, you're actually more likely to become more nearsighted because you don't have as much light. So in that instance, you could say the fact that people, if I wanted to have kids, if someone rejects me, it's probably not on the basis of me having eyes, so perhaps on me having glasses, not eyes. So in that respect, you could probably say that, yes, there is a decrease in the level of selective pressure on the trait of being nearsighted or farsighted.
But just,
yeah.
Just in general, evolutionarily speaking, eugenics is always going to be a dead end. I mean, if it's widespread enough, it's going to be a dead end because it's going to reduce your variation and it's going to narrow. It's going to prevent evolution, and then you're going to all die. That's how eugenics ends. And it's a question of how many generations. But if it becomes that prevalent,
so it would, I guess, then again, it would depend greatly on what the parameters of eugenics are. So, as you rightly say, eugenics would reduce variation, especially if it's very strong. And you could see, crops are artificially selected, and there is actually concern over lots of types of crops that are not very genetically variable because they've been selected to be big and juicy, but otherwise they don't really preserve much genetic variability, which makes them susceptible to disease. And as such, it's actually quite hard to reintroduce that variation. I guess, I don't particularly agree with eugenics, but if you were to say set up a dystopian or utopian society with eugenics, then perhaps you could be clever about it and try and make sure that the selection doesn't necessarily link your preferred trait with a bunch of other traits that would always go with it, to at least preserve variability at other loci.
But there's always going to be unforeseen developmental consequences. You select for one thing, and there's just going to be so many side effects. And natural selection is quite good at then selecting out those side effects, but I don't think we can do that on a human timescale.
I don't think so either. Obviously, if you had full and perfect knowledge of everything, then technically, yes, anything would be possible. But I can guarantee that right now we do not have anywhere near that capability.
So Max typed a question in the box. Audio problems.
We didn't
Max, can you?
Nicole's question.
Oh, Nicole. Okay.
Nicole's question first.
Okay, so Nicole, I believe she is also muted or unable to speak.
Ooh, I like Nicole's question. Okay, so I guess we can explore this by thinking about what Greenbeard was. So the question is actually for people watching. I have a question about Greenbeard and whether or not camouflage and mimicry are an example of Greenbeard, where the organisms look similar or have similar behaviors and would be inclined to be altruistic towards each other, but are cheating. So I would not say it's a Greenbeard. In fact, it's not really cooperation at all. It's really just someone who is cheating the system, and they're being selfish. So a Greenbeard just means that two individuals that have that trait can identify each other, but I don't necessarily know of individuals that mimic each other and are, say, non-noxious, but they're pretending to be or are just hiding from predators that would help each other out preferentially, other morphs of the same species that weren't cryptic. So I think I wouldn't necessarily say it falls under cooperation, in that they're not really helping any other individuals out. In fact, they're making it harder for anyone else who indulges in wanting to camouflage themselves, because the more edible mimics they are, the less likely it is for the noxious ones to perpetuate the system, because predators might occasionally eat the mimics and realize that they are edible, and therefore lose the connection between them being non-noxious.
Can I just ask you to clarify something there? So there's camouflage like a toad that looks like a rock, and then there's camouflage like a fly that looks like a stinging bee. Could you talk about the difference between them and how that relates to what you were saying?
One's camouflage mimicry, right?
Yeah.
Sorry.
Yeah, sure. So crypsis would be you blend into the background, and then there's Batesian and Mullerian mimicry, and I bet I'm going to get them the wrong way around. But one is where you have individuals that, say, aren't toxic but look such as a hoverfly. I think that's Batesian. Correct me if I'm wrong. So you have a hoverfly that looks like a bee, is imitating a toxic animal. But for instance, you have lots of bees and wasps that actually look quite similar to each other, because they're taking advantage of the fact that that pattern makes them look toxic. So rather than having the predator learn 5 different images of what a dangerous animal looks like, they just have to memorize yellow and black stripes, and that would be Mullerian mimicry. And Mullerian mimicry strengthens itself because you've got more and more animals that are dangerous or taste bad when they're attacked by predators, that they're less likely to eat them at all. Whereas Batesian mimicry, where you've got something that is tasty but is looking like something that's not tasty, then they're much more likely to eventually be attacked if they are the majority of the population, and the predators actually disassociate their image with the one of a noxious predator. Hopefully that was better explained.
Yeah, that was great.
So, Mullerian mimicry is a positive feedback loop, and then Batesian mimicry is a negative feedback loop. So it's like it can become easily undermined. Is that the idea?
So Batesian would depend mainly on two variables. First of all, the actual noxious individual that they're copying. If it's incredibly noxious, such as instant death or very unpleasant, they could actually be relatively rare in the population, but predators are still more likely to remember it or have some form of stronger selective pressure to avoid it because the stakes are very high. If you accidentally eat it, you're dead. So if it was, say, a black widow spider and you had lots of black widow spider hawks, and the black widow spider bite was deadly to you, you just wouldn't risk it at all. And the other one is the relative frequency of the mimics in the population. So if it's 99.9% edible critters that look like something that's non-edible, they're much more likely to be caught out and sampled by a predator who will then discover that actually most things that look like a bee are actually flies and are perfectly edible. So it's negative frequency dependent and also an element of risk.
So there's this, what can we call cooperation and what isn't, right? Like, would we want to say that the bees and the wasps and the yellow jackets are all cooperating with each other by looking like each other, whereas the fly that's mimicking is cheating? That feels like it's pushing the words a little bit further than we want to use them. But why would that be the case if it is?
So if we go back to the graph, you want to think one of the conditions of it being cooperation from an evolutionary perspective is you've got to be able to say it's evolved at least partially in that way. So I would say, I think you can claim that malaria mimicry would be a direct fitness benefit because you're less likely to be eaten, and if there's a large population of you that are stripy and look not very tasty to eat, then you're much less likely to be eaten. So it pays to look a lot like those other individuals, and you're mutually benefiting each other. Of course, the Batesian mimics are basically the cheats. So you could either expect it to be unstable cooperation eventually, whereby the system breaks down if the mimics actually grow to be so large in population that the effect of looking like a noxious organism is no longer that helpful for them. So you could either expect an element of enforcement, or you could expect perhaps the noxious insects will shift in their appearance. I'm not so sure you'd call it cooperation though, because I guess the bees are technically helping out those other organisms, but they're not obtaining any direct benefit back. So in that case, it's more of a byproduct.
I've got a question about and my video kind of lagged when you were talking about it, but gene or kin distinction and stuff. So if siblings were related, they have the same parents. Is there any studies or anything about like half siblings or anything like that in cooperation? Like if you covered that in the video, I'm not sure, but like I said, it broke up, and I was really curious about that.
So I'd have to look in the literature, but basically, the less related you are, the larger the benefits overall have to be in order for it to actually add up and be beneficial to you. So if an organism was, say, a cooperative breeder, and it was helping a half sibling, if their help could really help them have 3 or 4 more offspring, it would actually add up to a point where they would derive positive inclusive fitness. The benefits would outweigh the costs. I also think it's quite common for there to be an element of error in kin recognition and kin discrimination, because it's usually based on cues that are usually correct but aren't necessarily surefire ways. It's more based on correlation than actual causation in these cases. So if on average it works out, it's probably a case that they're usually helping siblings, but occasionally they're helping half siblings. And I guess if you think of the case of eusocial insects with multiple queens or queens that are multiply mated with different drones, you would also have a lower relatedness in the nest, but in the end they're all cooperating together to help the queen produce more workers and also the next generation of queens and colonies. So overall, net perspective, the inclusive fitness calculations would most likely work out. I don't know any studies specifically, but that doesn't mean they don't exist. It just means I'm not familiar with the literature, and I could probably have a look to see if there's anything on more related than average, but not 0.5 relatedness values.
I've been trying to digest all these different ideas and explanations for cooperation and think of different examples of where each one works, and well, there's a lot of overlap. And I was wondering if you knew of any examples where limited dispersal was not a thing, because it seems like it's almost always prevalent in groups. Because they reproduce with each other, you're going to have your siblings nearby. So are there examples where there's a lot of spread?
Okay. So these are just thoughts I'm having. I guess you could think of, say, organisms like salmon that perhaps are all born in the same location but might migrate somewhere else to breed. Some might migrate back home to breed again. So in those cases, you might not expect cooperation based on proximity or limited dispersal. But also in those cases, if you're actually dispersing away from your family, you're less likely to encounter related individuals to help. So you might not even expect cooperation in that sense to be present. But I do feel that those that use genetic cues, such as insects, they actually do have facial recognition. Some of them, some wasps can actually memorize the faces of other individuals in their colony. Where you've got the ants who are very good at discerning cuticular hydrocarbon profiles, and it's actually a little bit more complex than I let on in the live stream. So obviously you get cases where there is actually quite a lot of genetic variability in the nest, and they actually just memorize an average profile. So again, those cases, it's based almost entirely on scent that's probably genetically coded, but not so much on, or scent of the nest, but not so much on.
Okay, I'm just looking for exceptions right now.
I'm sure they exist though, because it's biology.
The prime exception is humans. You know, you could take a flight to India and walk around, and someone will probably help you. Someone might also take advantage of you, but like we are quite good at cooperating with other humans that are far away. But it's a really good point that, like, you know, the heuristic that most living things use is just if you're close by, you're probably related.
Yeah. Sorry, I'd understood it as examples of kin recognition when away from the nest, or when reared in groups. I'm sure it exists, and to be honest, I'm sure there are plenty of animals where we don't understand how they're actually recognizing or discriminating between each other. So I mean, even though the work on these long-tailed tits and the superb fairy wren, that's things that, you know, take several PhDs, several years to look at. So it would take, I would imagine, most species, we don't even know how it is they identify each other. But by doing these experiments of putting unrelated organisms amongst otherwise brothers and sisters, it's easy to tell if it's environmental and situational, which tends to work quite well, or if there is actual genetic detection based on its use.
Because when reciprocity and stuff works out, it's really interesting, and now I'm really curious if there are like good examples where they do these behaviors not because of like the being related, but because of the benefits of reciprocity or increased survival rates or things like that.
Yeah, so there is, I know it's exactly not what you're interested in. There's a lot of literature on limited dispersal, and Stu West has done a lot of work on that. But I actually think if you drop in an email, or I could ask him, he might actually know examples of animals that don't meet those requirements, precisely because it's something he's studied so much.
That's cool.
There are a couple mechanisms operating in parallel here, right? There's you're related to me. These are my genetic relations, and I might be closer to you. I might be in more physical proximity to you, and we might be able to help each other because we're genetically related, right? And we share our helping genes, right? Or there's my ability to detect you as kin, and then assortative mating, assortative behavior, assortative relating, right? Based on you being kin. But then there's also individuals being able to assortatively mate or assortatively relate to one another just based on the fact that I see you being a helper, and I'm going to want to help you because you're a helping kind of person. And that really, when we get into, you know, the mathematical modeling, it's hard to provide an account for that, of being able to assortatively relate to individuals within a group who are demonstrably more pro-social, more cooperative than others. And we see that especially with the more behaviorally complex organisms like primates, like us, meerkats, things like that.
Mm-hmm. Yeah, so is what you're asking, how do we identify between them, or how do we quantify that?
Me?
Yeah.
I was just trying to parse out a few different mechanisms of assortion, because you need some selection within a group of, I mean, just, you know, Prisoner's Dilemma say you need some ability to choose who you're going to do business with, who you're going to consort with. Otherwise, the equilibrium fall apart and you get pushed to defectors.
Yeah, so are you referring to helping, or are you referring to, say, sexual selection, such as what mechanisms go into an individual discerning whether it's a good mate or one to avoid?
Just behaviorally, just in terms of reciprocity.
I feel like I'm not fully understanding the question, but that might be a result of me just being very tired at the end of the day.
It wasn't really a question. I was more just clarifying for.
But what
we are running close to time. We have maybe 5 more minutes or so. So I do want to get to Max's question that he typed into the comment box, because I'm particularly happy to have you here, Inés, because of the work that you've done with Draw Curiosity, and I would love to spend the last bit of the conversation talking about that. So maybe Max, you could chime in and we can close off in that way.
Sure. Inés, you could open your window too if you want. You know, it's looking like, you know.
I think I might actually do that because it is. It is very noisy when the cars go by, but hopefully people aren't driving home anymore. I'll be right back.
I mean, I have my window open right here. I don't know how noisy it is wherever you are, but we get by.
A good fan though. It was a really nice prop interlude.
Much better. My house is a blooming greenhouse.
Okay, so my question is really just what your process is like. I mean, part of what we're doing here is going to be taking this live stream and then trying to make a video to create some sort of narrative. And clearly, your videos are of high production. I don't know how much help you get. Obviously, there's some animation and some different parts of some different elements of your videos, but I'm just kind of interested in what your process is like, and maybe if you can give us any advice as, you know, we're trying to learn more about online video and editing and animation and different styles of communication.
Okay. So my videos, I actually make most of the stuff myself, with the exception of the introduction. What I would say, to start a video, I would think, what is the message that you want to convey? And how clear do you want that message to be? So it could be a story. You could, for instance, have the story of the vampire bats and how we find out about what cooperation is and could be through that. Perhaps you want multiple storylines, but obviously the more you pack in, the more complex it is, so the more you have to think about the script. Or perhaps you want to keep it, so you might want to use repetition to drive a point across, or you might want to keep it very simple. But ultimately, I would start with, what is your core message that the person watching this video, if they were to summarize it in 1 to 3 sentences, what do they take away from it? That's where I would start from. Then, I generally find, so if this is the time it takes to make a video, you can either spend a lot of time in pre-production, which will make post-production very streamlined, or you can wing it a lot at the start and then smash your head against the desk later on. So I usually spend quite a long time preparing a script. Some people like different styles. I think for science, I almost always use a script. I have occasionally done a bit of riffing or just an outline, and I think I did the potato battery one, which I didn't really plan at all. I just wanted to see what would happen. But generally, you want to have a story in line. You want to know where your video is going. I think the way you make a video is entirely up to each person's creativity. So I don't really want to say to people, you know, this is how you should place the camera, or this is how you should do it, because from seeing Max's videos, I think there's quite a lot of creativity in there, and I want to encourage that as much as possible. But basically, having a set of goals you want to achieve, both in terms of message and maybe streamlining, you know, you want to have a rough cut done by the next day, and maybe identifying where you want to add effects or stop motion or whatever creative piece of media you want to include. If you sort of plan those out in advance, later when it's all coming together or falling apart, it will be easier to do that. But ultimately, it's about the content. So having that clear message, being able to summarize it, and for someone to watch it and go away and say, yes, cooperation kind of all through these, can be maintained through these 3 different ways. Or vampire bats, their cooperation, we don't really understand fully what causes it, and here is potentially why.
Do you memorize your script, or do you use a teleprompter, or how do you translate the script into performance?
So I used to memorize, and then I did get a teleprompter. Both have their pros and cons. The weird pro I found is that a teleprompter makes me blink a lot less, so people will stop complaining that I'm blinking 100 times per hour when I'm memorizing. I think that's entirely up to you if you want to use a teleprompter or a script, or just memorizing the script. I think memorizing, especially if you're starting out, is more tedious, but it can also look more natural. I think you can master the art of making a script look natural, or writing a script for it to be exactly how you would say it. And if you have the chance to do so, I would actually say do both, because normally when I do a script, there's always some technical part I just can't memorize, even if I try. So it's great to be able to read that, even if it's just a voiceover, or to read it from a teleprompter. And then there are other bits where I can explain it backwards without even reading a script, where I'm super passionate about it, so I want to go at my own pace, and then I will ditch the teleprompter and just say it as is. So I'd say use it if it helps you, but there's no correct way of doing it. I think it does save time though. I always know how long a video is going to take to film when I have a teleprompter. That is not the case when I'm memorizing.
The other thing I was wondering is, what is your process for making animations? Because the animations in your videos are quite well done, and you must be doing some pretty sophisticated coding, because you've got, like, you know, sometimes 20 moving objects on the screen.
So I use a software that's actually completely free. It's not the easiest to use. It's called Blackmagic Design Fusion 8. It's a node-based program, which means I had to watch a lot of tutorials to even understand what it was all about. You've got a 2D platform, you've got a 3D platform, but there are lots of little tricks and things you can do. So for instance, when you want lots of elements, I can actually create it once and duplicate it as many times as I want. I can introduce some randomness to move them around. So I don't have full control over it because I don't actually code into the program. I would probably have to actually take a course in the software to be able to do that reliably because I don't know what language it scripts in. It is definitely a learning curve when I start. I mean, again, the video I played in the middle, that was from a year ago, and I sort of cringe a little bit when I watch it, both in terms of how I made it. I think I would do some things quite differently, but it also shows how you progress. So I'm sure the first videos you make, when you look back on them, you might think, oh, I don't like that quite so much, but you'll see the progress. If anyone has Adobe, Adobe After Effects is meant to be quite good. There are lots of tutorials. You can also download a lot of effects. I've not found so much for my software, but the nice thing about my software is that it's completely free. And I know people who animate in PowerPoint as well, and then they just do a screen capture of the PowerPoint. So I wouldn't worry too much about the animations, which way you choose to use it. I don't know anyone else who animates in Fusion, but it works for me and it's free.
So can you, maybe we'll close on just that comment you said about, so you've seen yourself improve over the last year. So what has that been like, going from not knowing much to being where you are now?
I mean, I say video making is definitely learning by doing. So before starting, I did watch a lot of tutorials, but ultimately you have to make something and then you watch it back and you see, actually, this setup, like having the camera at this height and I'm closer to the camera than the background, that works really well and it looks really nice. And sometimes you have to screw up as well. So like the video I played, I hate the framing I had. I forgot how short I was and like pointed the camera up. So there's like, the original frame was even worse. I think it was like my head and then a load of empty space above me, and it just looked very weird. But really you only find that out by doing it. So to be honest, I would just say experiment as much as possible. Always do more than one take. So everyone who makes videos, they watch the YouTube video and they think, oh my God, people are amazing. They do one take and it just comes out straight away with no mistakes. It's never like that. You get people stopping and starting, getting stuck on a sentence, and that's quite normal. So I would advise doing several takes, even if you've got a teleprompter, and then you can choose the best bits from each one. And there will always be a take you screw up. Maybe you forget to turn the microphone on. Maybe you're using natural light and this big cloud goes by and the light is thrown off. So have repetition, and that way you get to learn more because you've tried out more things. But I would say, yeah, definitely experiment a lot, because the video I've seen, I don't know, am I able to watch the videos that everyone else makes? I would actually really love to see what you'll come up with.
Yeah, they're on a separate channel, but I will send you an email with it. There's a couple on there now. I was watching them right before we went. They're splendid. I've seen Max and the video, and they really make me smile.
Because yeah, I saw your video. I thought, this is great. I mean, I don't want to give too much advice because I don't want to push anyone to follow a particular route for their videos. I want to see what you come up with and ultimately let your style shine through. So yeah, keep doing what you're doing. It's great.
Okay. Well, with that, I think we will close. But thank you so much, Inés, for this chat and your lecture. It was really cool to be part of that live stream and then to have you here. So thank you so much.
That's all right. Thank you so much for having me.
So yeah. I'm gonna. There's a few more things I want to say to the class, but when Inés leaves, I'll stop the broadcast.
Okay.
Yeah.
Cool. Well, it's lovely to meet you all. Best of luck with your projects, and it's been really fun being a part of this. Thanks for inviting me.
Bye. Thanks.
Thanks for coming.
Yeah.
Bye.